Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
University of California, Riverside, ecologist Erin Wilson-Rankin didn't set out to study hummingbirds. A few years ago, she and her then-postdoc Sheena Sidhu were conducting a field experiment on campus to see if honeybees avoid feeding on flowers with ants on them, something that could spare them harassment by the aggressive insects. It turned out that the bees indeed spent less time on ant-occupied flowers, and so, it seemed, did local hummingbirds. The charismatic, little birds, as Wilson-Rankin describes them, would fly up and then quickly move along, opting not to plunge their long beaks into that flower's nectar. A follow-up study confirmed the observation. Like the honeybees, hummingbirds avoided flowers, or feeders, when ants were present. The researchers knew that the bees were using smell. The pollinators preferred feeding on flowers that didn't reek of ant pheromones. But what about the birds? While the scientific community has long since discarded the old belief that most or all birds are anosmic, the olfactory bulb in most avian species is small, and hummingbirds have incredibly small brains to begin with. Conventional wisdom was that if you have a really small olfactory bulb, and very few neurons that are associated with olfaction, you're not going to have a very good sense of smell, Wilson-Rankin says. Sweet scents. A male Anna's hummingbird, Calypte Anna, on a feeder David Rankin to dissect the observation. The team designed a new study that allowed hummingbirds to choose between a feeder with plain sugar water and an identical feeder containing sugar water laced with one of three chemicals, cuticular. Chemicals produced by insects, says Wilson-Rankin. They might not have many olfactory neurons, but they use those neurons to avoid dangerous situations. Other birds appear to use smell to find food. In a study published the same month as Wilson-Rankin's hummingbird experiments, conservation ecologist JUAN LUIS CELIS-DIEZ of the School of Agriculture at Pontificia Universidad Católica de Valparaíso in Chile and colleagues found that artificial prey worms placed on tree branches were more likely. That study found that insectivorous birds were attracted to a pheromone that female winter moths, Oporoptera brumata, use to attract mates. Smell in birds is more common than we thought before, Celis-Diez tells the scientist. More than half a century later, Iwaniuk and his colleagues found that the turkey vulture, Cathartes aura, has perhaps the biggest olfactory bulb of all birds, along with a high number of olfactory neurons that link the nasal cavity's smell receptors with the brain, features indicative of a particular. Alongside work on the anatomical basis of smell in birds were functional studies showing that vultures, and later wandering albatrosses and other seabirds, can pick up the scent of food, carrion in the case of vultures, and chemicals released by plankton on the ocean surface in the case of the wand. Decades of work starting in the 1960s has also demonstrated the importance of smell for homing pigeons' navigation. Now we're in almost a renaissance, if you will, in studying olfaction in birds, Iwaniuk notes. There's more and more people that are trying to determine what birds can smell. What kinds of cues are they paying attention to? What can they discriminate among? Wilson-Rankin's and Celis-Diez's recent studies, neither of which Iwaniuk contributed to, are two nice examples of that, he adds. In her work on hummingbirds, we built on the work of others that found that just because you don't have a lot of olfactory neurons doesn't mean your sense of smell isn't important in certain contexts. Quote, "Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you."